A solid hemisphere has volume 230 centimeters cubed. A. Calculate the radius of the hemisphere. The question gave us the volume of the hemisphere, and the question also gave us the formula to find the volume of a sphere with radius r. A hemisphere is just half a sphere. Therefore, the volume of a hemisphere can be found from half of the formula of the volume to find a sphere. So if we knew the value of the radius and we used the formula 2 over 3 pi r cubed to calculate the volume, we should get 230. So we can write 2 over 3 pi r cubed equals 230 and use this expression to solve for r. B. A solid cylinder with radius 1.6 centimeters is attached to the hemisphere to make a toy. The total volume of the toy is 300 centimeters cubed. Calculate the height of the cylinder. The total volume of the toy, which is equal to 300 centimeters cubed, should be equal to the volume of the hemisphere plus the volume of the cylinder. We have already been given the volume of the hemisphere from part A. For the volume of the cylinder, we should be able to calculate given the height and the radius of the cylinder. The volume of the cylinder could be found from pi r squared multiplied by h, where h is the height of the cylinder. This means that 300 centimeters cubed, which is equal to the total volume, should equal 230, which is the volume of the hemisphere, plus pi r squared h, which is the volume of the cylinder. The question tells us that the radius of the cylinder is 1.6 centimeters, so we can substitute r with 1.6. And now we have an expression that involves h, the height of the cylinder, that we can use to solve for h. A mathematically similar toy has volume 19,200 centimeters cubed. Calculate the radius of the cylinder for this toy. Whenever the question says mathematically similar or similar, it means you need to use scale factors. If we let x equal the scale factor, when we convert between lengths, we multiply by the scale factor. But when we convert between areas, we need to multiply by the scale factor squared. And when we work with volume, we need to multiply by the scale factor cubed. We are given the volume and the radius of the original toy from part 1. And we are given the volume of the mathematically similar toy in this part of the question. So we have volumes of both toys. Therefore, we can use the volume to find the scale factor. As the volume of the original toy multiplied by the scale factor cubed should equal the volume of the mathematically similar toy. And we can use this expression to solve for x, which is the scale factor. Once we have the scale factor, we can use the radius of the original toy to work out the radius of the mathematically similar toy. To convert between lengths, we multiply it by the scale factor once, so the radius of the mathematically similar toy should equal 1.6, which is the radius of the original toy, multiplied by the scale factor, which equals 1.6 multiplied by 4.